Hi everyone. Today I'm going to go over your activities 11, 12, and 13 quiz review. Remember to read through these I can statements to see if you know what you're doing for your quiz tomorrow. So make sure you guys go through those after you have completed this, all right? And go ahead and do check marks and remember to highlight any of these topics that you are still struggling with. All right, let's get started. So transformations of quadratic functions in vertex form. Real quick, I want to review the parent function of a quadratic function is y equals x squared. Remember the x squared part makes it a quadratic function. All right. Now it says what are the values of the parent function of a quadratic equation? Then graph it. All right. If I type this into my calculator, the x squared term, remember, this is what it looks like graphically, but I want us to write down some values over here. So let's go ahead and look at that table of values. All right, if we look right here, these y values start to repeat, right? So that number in the middle, or that coordinate point in the middle, that's where our vertex is. And I do want you guys to graph your vertex. So the vertex is 0, 0, and then label that as V. And then remember, I want you to plot 2 points to the left and 2 points to the right of that. So here, which in the table values, I mean above and below. So 2 points above that would be -1 and 1, and -2 and 4. And 2 points below that are 1 and 1, and 2, 4. And I just got that right off that table of values right there. So I'm going to go ahead and graph those. 0, 0, 1, 1, 2, 1, 2, 3, 4. And -1, 1, and -2, 1, 2, 3, 4. All right. Connect these. Remember, this is a U shape, not a V, so make sure it looks like a U and not a V, please. All right. So this is something you guys can refer to go back to once we are starting our transformations. All righty. So it says the vertex form of a parabola is a times x minus h squared plus k. Remember, we're not doing the b value, so that's all I left there for you guys. So transformations, quick review. The negative out in the front of the a means that we have a reflection over the x-axis. You just write reflects over the x-axis, that's fine as well. Okay, but make sure you include that there's a reflection and that it's over the x-axis because there is such thing as a reflection over the y, we just haven't got to that yet. All right, the a value tells you if you have a vertical stretch or shrink. If a is greater than 1, you have a vertical, think about it, if it's greater than 1, it's going to be big, so it's going to be a vertical stretch. Okay, if the a value is less than 1, it's a vertical shrink because it's smaller than 1. Okay, and we say that it's greater, we say less than 1 and greater than 0 just because remember the negative, if we have a negative out in front of the a, that's being taken care of by the reflection, okay? All right, this h value tells you if you move left or right. If it says x minus h, you're moving to the right because h is positive. If it says x plus h, you're moving to the left because h is actually negative there, okay? And then k, if it says plus k, you're moving up. If it says minus k, you're moving down. All right, so let's do some practice. All right, number 2 says, describe the transformations, describe the transformations of the following functions. All right, so looking at all of these just have my h and k value. So because this is x plus h, all right, that means we're going to move to the left 3. And this plus 4 means we're going to move up 4. Alrighty, letter B. Again, this says x plus 3, which means we're moving to the left by 3. And this minus k value means we're moving down by 4. Make sure you guys include that number so I know that you know which transformation goes with which number. Okay, letter C, because it says x minus h, this is right 3. And this plus 4 means up 4. All right, again, we have x minus the value inside the parentheses, so that's to the right by that value, which is 3, and this means down 4. Okay, so you guys can kind of compare the difference between left and right and then the difference between up and down, what those transformations look like. All right, so number 3 says, describe the transformations from the parent function, then graph the function. So let's go ahead and do that. Let's just look in this order here. So the transformations are, we want to compare it to the parent function, which is y equals x squared. So how many extra things do we see compared to this guy? Well, we have 1, 2, 3 extra things from the x squared. So we have 3 transformations. This 1/3, that's your a value. So we have a vertical, that's going to be a shrink because it's less than 1. So we have a vertical shrink by 1/3. This is in the form x minus a value, so this means we're moving to the right by 4. And then this is your k value, and it says minus k, so we're moving down 3. Now, you guys get to use your calculator on the quiz, so if I were you, I would just go ahead and type this in. So we've got 1/3 x minus 4 squared minus 3. If you remember from your notes, we did show you guys the order that you would graph these in, but because we're allowing you to use your calculator, I'm fine with you going on your calculator and just looking for the coordinate points. So it looks like the vertex is going to be somewhere over here, probably at 1, 2, 3, 4, maybe at x equals 4. Let's see if that's true. Yeah, it looks like it, because as you guys can see here, these y values start to repeat. So at 4, -3, that's our vertex. So 1, 2, 3, 4, 1, 2, 3. And then you guys see here that these y values repeat. That's how I know that for sure is my vertex. Okay, so let's plot these points. Let's see, 3, -8/3. -8/3 is -2.6. So 1, 2, 3, -1, -2.6 is about there. So that means there's one at 5 as well, because remember, there's a reflection at that axis of symmetry there. Let's see what else. 2, -5/3. -5/3 is -1.6. So 2, -1.6 is about here. So that means that that point's there too. So it looks something like this. All right, let's take a look at the graph. I'm going to go ahead and plot that 0 because I just want a prettier picture. 0, 7/3. You don't have to graph this point, but I'm just doing it to get a little bit of a better picture here. So it goes out like, whoops, like that. Okay. There we go. Alrighty, so now that we've got a nice picture, you guys are done. And you guys can also double check your transformations by saying like, okay, I know the vertex of a parent function is at 0, 0. My graph did move to the right 4 and it moved down 3. And looking at this vertically, it looks like my graph shrunk. So vertically shrinking would go like this way. The graph squishes this way, which means it gets wider. And that's what happened. So very good. All right, the next problem. Let's see how many transformations we have. We have 1. It looks like we only have 2 transformations, but remember that negative out in front of the a value is its own transformation. So again here we only have 3 transformations. So we have a reflect over x-axis. If you write reflection, that's the same thing. Okay, that 2 is technically greater than 1. It's not -2. Remember, the negatives are reflection. So the 2 is a vertical, and that's going to be a stretch because it is greater than 1. So vertical stretch by 2. Whoops, right by. And then that k value, that's outside of the parentheses of the x. Okay, if the number is, let me show you, if the number is inside the parentheses, then that means left or right. If it's outside, it's up or down. So because this 5's on the outside, it's up 5. Okay, all right, let's go ahead and graph this one. -2, oh whoops, probably be helpful to see it. X, oh whoops, let me try that again. -2 x squared plus 5. Alrighty, so it looks like my vertex is at 0, which is really nice. Yeah, okay, so let's see. Yep, that makes sense because here the y values start to repeat. So I have a, my vertex is at 0, 5. 1, 2, 3, 4, 5. So right at the top there. And then we have negative 1, 3. Negative 2. Negative 3. All right, and then I have those points. I have 1, 3, and 2, negative 3 as well. Yep. All right, and let's draw a little sketch. And if I compare that to the parent function, it obviously reflected because it flipped over the x-axis. Vertically, it's stretched, so it means it got skinnier this way, right? And it moved up. So very good. All right, number 4. It says each function graph below is a transformation from the x squared parent function. Describe the transformations, then write the equation of the translated function. So we want to write it in that form of y equals a times x minus h squared plus k. So we want to write it in that form once we find the transformations. Now, I suggest graphing the parent function first. So we have 0, 0. That the parent function was the very first thing that you guys did on the other side of this. 1, 1, negative 1, 1. Okay, so this is our parent function. We can't get the 2 and 4 in there. That's okay. All right, so clearly this graph reflects over the x-axis, right? Because our parent function faces up, so then the new one's down. So we have a reflect over x-axis. All right. And then, so this point's the same. This guy is not that exact point. So we did have 1, 1 and negative 1, 1, but now we have these two new coordinate points, right? Another coordinate point we technically would have on the parent function would be 2, 4 and negative 2, 4. So it looks like maybe these 2 and the negative 2, that these y values are just half of the new y values and it's reflected. So if we kind of make a table of values for the parent function, what I'm saying here is that we have the coordinate point negative 2, 4 and 2, 4, but it looks like this new function, we have negative 2, negative 2, and 2, negative 2. If you compare these y values, you really just multiply them by negative 1/2, right? 4 times negative 1/2 would be negative 2. So the negative comes from the reflection of the x-axis, and then this would mean that we have a vertical shrink by 1/2 because we multiplied the y values, which is the vertical, we multiply them by 1/2, and so because it's smaller than 1, that's a shrink. So when we write out this function, it would be y equals negative, because the reflection, the a value was 1/2, and it's just x squared because we do not have a shift left or right, and we don't have a shift up or down. And you guys can always go back into your calculator, whoops, and double check to make sure those values make sense. And I'm actually just going to look, yeah, so I have negative 2, negative 2, and 2, negative 2, and that graph looks just like this guy right here. Okay? Alrighty. Letter B. So let's draw the parent function. Alrighty. So it looks like this vertex moved 1, 2, 3, 4, 5 to the right and up 2. But we need to see if these other points do the same thing. So 1, 2, 3, 4, 5 up 2. Okay, that matches. Let's try this one. 1, 2, 3, 4, 5 up 2. That one matches. 1, 2, 3, 4, 5 up 2. All right, so clearly this is working. So this is just a right 5 up 2. So how do we write that? y equals, there's no a value, so I don't need to write anything in there. My function moves right 5, so I'm going to show that as x minus 5. And remember, x minus shows to the right. You got to square it, and then we have up 2, so I'm going to put plus 2 for my k value. And like I said, you guys can go back into your calculator and double check that those points match up, but that one was a little easier. These would be, you might see something more like this on your quiz, but this would be like the hardest one type of problem that we would give you, okay? Alrighty, next page. We've got standard vertex form. It says, what is the vertex form of a parabola? We already know that. It's y equals a times x minus h squared plus k. So number 5 says, write the following equation in vertex form. If we follow the directions from our 11.3 notes, or was it 11.3? I believe it was. Let me double check real quick. Yeah. All right. So first we need to identify a and b. So a is -2 and b is 12. Let's see, negative and 12. Okay, good. Now we got to find h and k. Remember, the formula for h is negative b over 2a. So I have negative, my b value is 12 over 2, and my a value is -2. Negative b over 2a, good. All right, so -12 over 2 times -2 is -4, which that equals 3. And then my k value, remember, you just take this h value and plug it back in for x right here. So I have -2 times 3 squared plus 12 times 3 minus 17. And remember, you guys can just type that into your calculator just like you see it. So I have -2 parentheses 3 squared plus 12 times 3 minus 17. All right, and that equals 1. Okay. All right, so that's, now I have a, h, and k, I can just plug them into that equation. So y equals, my a value is -2, h is +3, so you write that as x minus 3, and then k is +1. All right, and that's it. Alrighty, remember, just a little side note, if your h value is negative, then you would have x minus whatever that negative number is. And that's what would be in your squared. So this is only if h is negative. Just be careful with that. Then you would do that. So that's why it would become x plus the value. Alrighty, that's just a little side note. Okay. Next, we want to talk about the key features of quadratic functions. Some of this is repetitive, guys. Remember, the vertex is just hk, all right? And we know the formula for h is negative b over 2a. We just went over that. And k equals whatever f of h is. That just means you plug the h value in for x to solve. The axis of symmetry is x equals whatever that h value is. Remember to write x equals because it is a line. The x-intercepts, that's where the graph touches the x-axis, and that is also when y equals 0, and we can solve for those by either using factoring or we can use the quadratic formula. Y-intercepts, that's when you plug x in for 0, all right? And it's also, you could just say it's the C term, you'll notice that when you're in standard form only though. Okay, max and min value. The max is the highest point on the graph, so it would look something like this. And the min would be the lowest point on the graph. And then the values of those, the value, that's just the y coordinate of that highest point. So it's really just the k value of the vertex because the max and the min are technically that vertex. All right, the direction of the graph opens up if a is positive, and it opens down if the a is negative. All right, so let's talk about the key features here. So you guys will have one problem just like this on your quiz that you'll have to go through. So it says find the listed key features, show all of your algebraic steps, show your work, and then graph the function. So this vertex, I do want to see your work. I asked for it, so I want to see it. So remember, the vertex is HK. So H equals negative. My B value is negative. So do parentheses, negative 8 over 2 times my A value is 2. So 2 negatives make a positive. 2 times 2 is 4. 8 divided by 4 is 2. So, all right, my vertex, I know the H value is 2. K is when I plug 2 back in for X right here. So 2 parentheses 2 squared minus 8 times 2 plus 7. Let me make sure I type or plug that in correctly. Okay, good. And then let's type that in. 2 times 2 squared minus 8 times 2 plus 7. Negative 1. All right, so that's done. The y-intercept, remember, that's just when you plug 0 in for x. So that work is just going to be 2 times 0 squared minus 8 times 0 plus 7. Well, 0 times anything is 0, so it's really just 7. So my y-intercept is 0, 7. I ask you to write it as a coordinate point, so please do. The x-intercepts, that's when we set a y equal, or we plug 0 in for y. So this is really just y equal, or 0 equals 2x squared minus 8x plus 7. All right, and we either need to factor this or use the quadratic formula. Let me see if this is factorable. I know my only factors of 2x squared are 2x and x. If I put a 7 here, that gives me 14. That's way too big. If I put a 7 here and a 1 here, yep, that's not factorable. Okay, so we gotta use the quadratic formula, which is fine. All right, x equals negative b is negative 8b squared plus or minus the square root, or I'm sorry, negative b, my bad, plus or minus the square root of b squared minus 4ac all over 2a. All right, if you want, let's actually go back and write down what that quadratic formula is. X equals negative b plus or minus the square root b squared minus 4ac all over 2a, just in case you forgot it. Alrighty, so let's go ahead and simplify this. This gives us positive 8 plus or minus the square root of negative 8 squared minus 4 times 2 times 7 of 8 all over 4. So we have 8 plus or minus the square root of 8. We can simplify. Whoops, sorry, I'm trying to make sure I don't lose the screen here. So we have 4 and 2 and 2 and 2. So because I have a pair, I take it out, so it's 2 squared of 2 because I have that 2 left as a loner. So I have 8 plus or minus 2 squared of 2 over 4. 8 divided by 4 is 2, plus or minus 2 divided by 4 is 1/2 the square root of 2. So let's go ahead and write those. I'm going to figure out what that is in a decimal form so it's easier to graph it. Sorry, moving my paper around. All right, so 2 plus 1/2, whoops, square root of 2. So I have 2.71, and I have 2 minus 1/2 square root, whoops, 1.29. All right, yep, okay. Sorry, just making sure I typed that in right. And then my axis of symmetry is just x equals, that's why it says don't forget something silly here. That's the x equals part. The h value, which we found earlier, was 2. And this graph is going to have a, let's see here, this graph faces up because a is positive, so it's going to have a minimum. And that minimum is, the value is just the y-coordinate of your vertex, because remember the minimum is also the vertex, so it's -1. Now we can double check those two things once we graph it, but let's go ahead and do this. So I have the vertex is 2, -1. My y-intercept is 0, 7. And I have an x-intercept at 2.7 and at 1.29. And I have my axis of symmetry at x equals 2. So remember that's a dotted line because it's not part of your function. All right, and remember the axis of symmetry shows where your graph is or where your parabola is symmetric. So these distances are the same from the axis of symmetry. So if I'm 2 points away from the axis of symmetry here, that means I can be 2 points away from the axis of symmetry on that side as well. Then I can connect my coordinate points for a nice pretty graph. All right, and yes, this graph does have a minimum, and that y value is -1. Okay, you guys could graph it back in your calculator and double check it, but I am going to require all this work, okay? All right, lastly, solving systems graphically and algebraically. Graphically, remember, you're just going to go into your y= screen and graph the two equations as y1 and y2, and then you're going to adjust your window to find the intersections. Maybe there's only one intersection, but you want to find the intersections, okay? If you're solving for systems algebraically, you're going to set the equations equal to each other. Then, because we're giving you a linear and a quadratic function, go ahead and set the quadratic equal to 0 by combining your like terms. And then you're going to solve for x by either factoring or using the quadratic formula, which we basically already went over how to do up above. So, right here, I just have some calculator window help. If you need to see more of the right side of your graph, remember you're going to change the x max. If you need to see more of the left side, you'll change the x min. If you need to see more above, you change the y max. More below would be the y min. So that's just kind of helping you refer back to that. Remember the number of real solutions that you have when we ask you to identify how many there are. If you get 2 answers, that means you have 2 real solutions. If you only get 1 x value, that means you have 1 real solution. And if for some reason you end up with the square root of a negative, remember the square root of a -1 equals I, which means it stands for an imaginary solution. So if you have imaginary solutions, that doesn't mean you have any real solutions. So you would have 0 real. We are only asking, number 7 says solve the system algebraically and for the real solutions. So that's why you don't need to identify the imaginary. I just want to know how many real. So it's either going to be 2, 1, or 0. Okay? All right, then it says check your solutions graphically and identify the number of real solutions. You will be asked to do one problem algebraically and one problem graphically. Just for the review purposes, I'm having you work on the same problem both ways, all right? So algebraically, we're going to set the equations equal to each other. So I like to write the quadratic on the left-hand side, but it really does not matter. X squared minus 3 minus 1. Okay, and then set the quadratic equal to 0. So I'm going to subtract by 4x. I'm going to add 11. I like to line up my terms so they're equal. So this gives me x squared, -3 minus 4 is -7x. 11 minus 1 is 10, and this equals 0 because those cancel out. All right, now I want to see, now I got to solve for x. So I'm either going to factor or use the quadratic formula. I think this is factorable, so let's try it out. Let's see, factors of 10 are 5 and 2. If I make them both negative, that gives me -5x, -2x, which gives me -7x, and -5 times -2 is +10, so awesome. So then now, to solve for x, I'm going to set each of these factors equal to 0. And solve for x. So x equals 5 and x equals 2. Because you have to add 5 and then add 2, right? All right, so here I have 2 real solutions because I ended up with 2 x values, okay? You need to have all that. All right, graphically, let's look at it. So in my y1 screen, I'm plugging in the first equation, so 4x minus 11. In my y2, I'm going to plug in x squared minus 3x minus 1. So there's my linear function. And here's my quadratic. Oh, awesome. So it looks like they intersect again up here somewhere. So I'm going to go to my window and change my my x max and my y max a little bit. So my x max, I'm going to make 15. I'm going to make my y max 15 as well. So I want to see that top right corner. There we go. That's better. All right, so to find the intersection, remember you hit second trace, intersect, and move your cursor to where you think the intersection is and hit enter 3 times. So 2, -3, that's correct. Oh, I forgot to sketch a graph. Sorry. So I have here and here, right? Those are my intersections. So this was at 2, -3. And then over here, gotta do it again. So second trace. Oh, whoops, did not hit trace. Let me go back to it. Okay, second trace, number 5. Go to your intersection, hit enter 3 times. 1, 2, 3, 5, 9. So you have 2 solutions here as well. And I just forgot, we forgot to find the y values, guys. That's my fault. You have to find the y value on your quiz. So don't say that this is your final answer. That's 100% my bad. Totally forgot. Okay. See, you learn from your mistakes. Alrighty, so let's go back and show the math. We know that we should, for 5, get 9, and for 2, we should get -3, but let's go show that work. So you can show that work by simply plugging in this x value into either equation. I'm going to do the linear because I think it's going to be less math. So y is going to equal 4 times 5 minus 11. 4 times 5 minus 11, we get 9, which makes sense because we have a coordinate point 5,9. And then for y equals 4 times that x value of 2 minus 11. Let's type that in. 4 times 2 minus 11, -3. So this would be 2, -3. And like I said, that makes sense because those are the solutions we got graphically. So if you ever forget, you guys can go back and use the other method to double check, but I will ask you to, on one problem, solve algebraically, and on a different set of equations, solve it graphically. So make sure you know how to do both. All right, and again, here you guys have 2 real solutions. All right, guys, let us know if you have any questions. Bye.